How exactly do stars form? The James Webb Space Telescope has peered deeply into dusty regions of space and is already helping us answer this and many more questions. Stars take shape over millions of years in super cold clouds that are filled with gas and dust. For decades, our views of developing stars were limited, in part by the technology of our telescopes. Either we couldn't see through dusty clouds to observe these stars, or we couldn't see them in enough detail. In only 3 years, Webb has supercharged astronomers' discoveries, reshaping what we know about star formation with its sharp near and mid-infrared observations. Webb's images and data, known as spectra, are so detailed that they have already led to immediate breakthroughs. For example, when Webb observed the Orion bar, researchers found intricate, never-before-seen ridges and waves in the gas where massive stars are actively forming. Massive young stars actively shape the environments around them with powerful stellar winds and ultraviolet light. Webb also precisely measured the chemical composition of the Orion bar, revealing many molecules in this region for the first time, including methyl cation, a pillar of organic chemistry. The telescope has shown us delicate, thread-like details in jets and outflows launched by smaller, still forming young stars. In Webb's observations of Herbicero 211, the inner jets seem to wiggle with mirror symmetry. This suggests that the star at the center, encased in thick dust, might be two stars. Before Webb, researchers often saw jets launched by actively forming stars in a variety of directions. In Webb's image of the Serpens Nebula, researchers immediately spotted a curious alignment. At least a dozen forming stars have outflows pointed the same way. The alignment of the outflows suggests that the stars formed along the same magnetic field lines, like spinning beads threaded on a string. Webb's images and spectra help astronomers definitively map where molecules and dusty ice grains are around young stars. Astronomers have pinpointed a range of ices in locations like the Chameleon 1 molecular cloud. Another first, the identification of frozen water in a dusty debris disk circling a sun-like star 155 light-years away. Scientists had thought that frozen water would exist around stars other than our sun, but before Webb's observations, it had only been identified in our own solar system. By comprehensively cataloging raw ingredients like these, researchers will soon figure out how they are produced around stars. Webb has also expanded where we can look. Now we can observe how stars form in other nearby galaxies in great detail. Millions of stars pop out in the spiral arms of galaxies like NGC 628. Its stars have also blown away gas and dust, clearing massive cavities. Within other galaxies Webb has observed, researchers have identified thousands of individual star-forming regions, found embedded star clusters, and detected individual stars that are actively forming. Webb will help astronomers piece together how star formation plays out within galaxies. The best part? Webb is only getting started. Expect to learn a lot more about how stars form in the coming years.